Hi students, today we're going to talk about the solubility and temperature lab. So as we go through this, make sure that you have a copy of the lab and you can follow along as I walk through it. Now the purpose of this lab is to construct a solubility curve for the chemical potassium nitrate. And we're going to do that by measuring the saturation temperature for 4 different solution concentrations. And so in order to complete this, we're going to need to make those 4 solutions and then determine their saturation temperature. After we do that, we're going to use our curve that we create in order to determine the concentration of a mystery sample that we do not know. So make sure that you read through this lab, read through the background. The background has several vocabulary terms: saturated, unsaturated, and supersaturated solutions. Make sure that we know what those terms mean. We're going to have different solutions that are occurring at different parts in our lab process, and we want to make sure that we use those terms correctly. Materials and safety precautions section, read those. All right, for the procedure, there are going to be some new techniques that we use this lab that allow us to collect data more efficiently and also to be more organized, because we're going to be creating 4 different sets of concentrations. And so as we go through the process, whatever step we're doing, we're going to have to do to all 4 trials. And so if you look at the data table, you'll see that this lab has more data than we have collected for some of our previous labs. So organization and preparedness is going to be important. We're going to have a water bath again. We've been using water baths a lot. We love water baths. We want to maintain it around 80 to 90 degrees, so anywhere in that temperature range is fine. Now you're going to have these 4 different samples, and we're going to be making them in test tubes. So one organizational trick is to use a wax pencil. Wax pencils look like really big crayons, and they allow us to write on the glassware, and then when you rinse it with hot water, you can rub the wax pencil away. So you're going to label your 4 test tubes A through D, and then you're going to use the beakers that are at your table in helping your test tubes stand up so you can carry them around to the different spots that they need to be in. So this is a picture that I took of some test tubes that I labeled. You can see I have tubes labeled A through D, and they're standing up in my beaker so that as I make my solutions, I don't spill, and this will allow me to move them to the water bath, to the balance, wherever I need to take them easily. Also, I won't be touching them. I'll be using my test tube clamp so that I'm not adding my fingerprints, which could influence the mass of my samples. Now, we want to measure the container empty first. And so we're going to use the tare method. Now, I know that you have used the tare button before. That is what makes our balance go to 0. But the tare method for removing some of our equipment, that's a new process. So here is how this tare method works. You're going to start with your balance tared out at 0. Then you're going to put one of the empty beakers on the balance, which will be used to help our test tube stand up, because we can't really just put a test tube on the balance. It needs a dish. So we put the beaker on. But I don't want to have to subtract out the beaker for each of my measurements. So if you hit the tare button again, then your balance will actually say 0 with the beaker on it. So now the beaker isn't a part of the mass at all. It's done the work for you. When you add in your test tube, it goes up by exactly whatever the mass of the test tube was, and you won't have to spend time subtracting out the beaker each way. So for this method, you're going to tare that beaker till it's 0, and then one at a time, you're going to put in test tube A, and then record the measurement. Take A out, put B in, record its measurement. Take B out, put C in, record its measurement, and so on and so forth. I have noticed that sometimes partners are working together in order to take a mass, where one partner stands at the electronic balance and shouts the numbers to their partner that's back at their table. Since for this lab, you have to record 4 sets of data every time you go to the balance, and you don't necessarily need 2 people to write down masses, it might be a better division of labor to let one partner do something else and have one partner go to the balance and record the numbers, instead of shouting them back to their partner at their station or saying the number again and again, 17.3660, 17.3660, as you walk back. It's just a funny thing that I've noticed that some of you are doing as you make your measurements. So by this point, we'll have the empty mass of each of our test tubes. While that's going on, the other partner could start getting our samples of chemical. Now, for our samples of chemical, we want to use the digital balances at our table. We're trying to get an approximate value of our chemical in these different ranges. And in the same way that we did the tearing on the balance, where we took out the mass of our beaker that was just there as a support, we're going to be using weigh boats to help us mass out our chemical. And we don't want the mass of the weigh boat to be included. We want to be somewhere in each of these number ranges for our chemical. So in a very similar method, you're going to have your weigh boat, which is just this little plastic dish. You're going to have the digital balance. You put the weigh boat on the digital balance, then you push that tare button. Now the weigh boat is tared, so now the weigh boat is not including any mass. And now you can add your chemical, and what number you see is actually the amount of chemical that you have and not the chemical plus the weigh boat. So you're going to pre-mass each of those measurements that are listed in that table, and then after you have massed each test tube empty, you're going to transfer the sample into the test tube so that you can then get the measurement of the sample and the test tube together. So after you have pre-massed out at your table with the digital balance, each of those different chemical ranges, A, B, C, D, and put the chemical in the test tubes, you're going to take those test tubes back to the balance, and you're going to, once again, in that same tare method, record the mass of each test tube with the chemical inside. So now there's two parts. There's test tube and there's chemical. You're going to go back to your station and you're going to add 2.5 milliliters of the distilled water. That is the water that's in the big jugs, not faucet water. Distilled water is pure H2O. You're going to use your barrel pipette to get a nice amount of water. And then you're going to take them back to the balance for a third time to get a measurement of the test tube with the chemical and the water. And that's going to allow you to figure out the concentration of your different solutions, since you'll have the precise measurement of your chemical and how much water was added. Once you've made all your solutions, then you can start using your water bath. So now you're going to place all your tubes in the water bath. They're going to go for a swim, and as they swim around, they're going to dissolve. Now what we're going to find is that the test tube A is going to dissolve first because it has the least amount of chemical, so it doesn't have to get very warm in order for our chemical to completely dissolve. So you're going to start with test tube A. You're going to take it out of the water bath. You're going to put it in the test tube rack, and you're going to allow it to cool. You're going to stir it with your thermometer, and then you're going to watch for when you start to see crystal formation. As soon as you see crystals form, then you're going to write down that temperature. That is the saturation temperature. It's the temperature at which the solution becomes saturated. Then you're going to repeat the process. Take your thermometer out, clean it off so you don't transfer between each solution. Grab test tube B, do the steps again for test tube B, then for test tube C, then for test tube D. Test tube D has the most chemical, so it should be the one that needs to be the hottest in order for it to completely dissolve. So as you're going through this process, make sure that the chemical has completely dissolved before you take it out of the water bath and allow it to start cooling. If there are still chunks at the bottom, use the thermometer to stir it around so that it completely dissolves, because you can't start the cooling process until all of the solid has completely dissolved into the water. Once you're done with all 4 of those solutions and you've written down each of those saturation temperatures, then you can go to the mystery sample in the hood. You're going to take a mystery sample, warm it up so that it dissolves. Then you're going to do the same process. Once it's completely dissolved, take it out of the water bath, allow it to cool, record its saturation temperature. Then clean all your glassware. By this point, you will have obviously completed your pre-lab and you'll have completed your data table. Now, the calculations, you're going to take the masses that you measured for all of those different test tube and test tube plus chemical and test tube plus chemical and water, and you're going to use that to figure out the mass of your chemical, the mass of your water, and then the mass ratio, and then the solubility, and then you're going to graph that solubility. So based on your 4 data points, you should have 4 different temperatures and 4 solubilities. You can use that graph, and then you'll answer a couple questions about your graph and reading your graph, and then also use your graph and the saturation temperature that you got for your mystery sample to estimate what the solubility was of your mystery sample. Make sure that you read through the lab, take the quiz, and answer that pre-lab question at the top of the third page. Have a great lab day.